Hi there, and welcome to this lesson on Further Pure Mathematics 1. We're on Chapter 8 and we're looking at proof by induction. And we're up to the final type of proof, proving statements involving matrices. Quick reminder of proof by induction. First of all, prove the statement's true for n equals 1. Assume it's true for n equals k. If that assumption is correct, prove that it's also true for n equals k plus 1. So, statements involving matrices. We'll have a look at one example together. There is only one example. If you want to have a go at doing this yourself first, then do. Pause the video and come back to me when you're ready. Okay, we'll have a look at this together. So the example says, given that a is equal to 4132, prove by induction that a to the power of n is equal to that expression. So we begin by saying what happens if n equals 1. If n equals 1, then the left-hand side, a to the power of n will be a to the power of 1. A to the power of 1 is just 4132. The right-hand side will be a quarter, and then we'll substitute 1 in for n. So that will give us this, placing 1 in for n everywhere. That simplifies to a quarter into 16, 4, 12, 8. All of those can be divided by 4, which gives us 4132, which is the same thing as we had on the left-hand side. So we've proved that this statement does work if n equals 1, that this is the same as this. Step 2 is just saying, well, let's assume that the result is true for n equals k. What that amounts to is substituting k into the expression. So we get a to the power of k is a quarter into all of this. Step 3 is where the work happens. In step 3, we're trying to prove that n equals k plus 1 is true if n equals k is true. So in this case, we're trying to prove that this red expression is true if the term before, this blue expression, is true for a to the power of k. How do we do that? Quite like some of the other proofs by induction, we look at a to the power of k plus 1. So we consider n equals k plus 1. And a to the power of k plus 1 is just a to the k times by a. But both of these things we know. A to the k we are assuming is that, so we can substitute that in. And a we know, we were told it in the question. It's 4132. Now comes a bit of matrix multiplication. So we'll get this times by this. So first row times by the first column gives us all of that. First row times by the second column gives us all of that. And so on and so on. The next row is tidying things up a bit. Here, for instance, we've got 12 lots of 5 to the k plus another 3 lots of 5 to the k. So that'll give us 15 lots of 5 to the k. Looking at the constant, we've got 4 take away 3, which is 1. Something similar happens for the other 3 terms. They can all be simplified, giving you this. What we then do is we take 5 out of each of these constants, and we bring that 5 into the power. So 15, the 5 from the 15 we put into the power, so we get 3 times 5 to the power of k plus 1. Same here, we put the 5 into the power, so we've got 1 times 5 to the power of k plus 1. And same again with the other 2 terms. Now the reason why we've done that is because once we've done that, we have exactly what we were trying to prove. So we've shown that as long as ak is true, so as long as n equals k is true, then the statement is true if n equals k plus 1, which is what you have to do in induction. The final thing is just writing down that we've done it. So that's what we were asked to do. Well, we've shown that the statement is true for n equals 1. We've also shown that if the statement is true for n equals k, then yes, it is also true for n equals k plus 1. Therefore, by mathematical induction, the statement is true for all values of n which are positive integers. Now, that gets us to the exercise, I think one good thing about questions involving matrices, I think all of them do have a very, very similar feel. I think certainly the majority are very like that last example that we did. Anyway, if you have the textbook, go to page 138, exercise 8D. That's the last exercise in the in chapter 8. So you could also have a go at chapter review 8 as well. Okay, that is the end of the lesson. Thank you very much indeed for listening, and cheerio.